The first thing to do is to select the Start default code, go into edit mode and delete all of the vertices apart from one of them. Use snapping to get the remaining vertex exactly on the x-axis so that the mirror symmetry will work correctly. At the top, click on the magnet, select increment and absolute grid snap and make sure that the magnet itself is toggled on. Then back in edit mode, move the remaining vertex onto the x=0 plane and then extrude it upwards. Turn the snapping off and constrain the extrusion by clicking on the Z to move up the spine. And then the legs can be extruded off to the side, the shoulder and arm extruded off to the side. Use the orthogonal view from the X direction to put the bend in the knee and the bend in the elbow, and add a mirror modifier in the X direction, and then I'll just add a skin modifier and a subdivision modifier. You need to change the thickness of the skin by selecting the relevant vertices and running mesh transform skin resize. But because the vertices will need individual thicknesses adjusting to make the right shape, it's easier to use the shortcut Ctrl-A with the specific vertices selected. You might need to adjust the positions up and down of the vertices to get the correct shape, as well as changing the skin resize with Ctrl-A and make the elbows narrow. It's a very approximate manikin that you're aiming to make here. So when it looks approximately okay, slide it up out of the way, and we're going to now create the Martian terrain. So add a plane, go into edit mode, subdivide it and scale it up. Then add a modifier to it. Use a displace modifier, which allows you to set a texture to control the displacement. So click on the texture option, or use the texture properties at the bottom and select a noise texture, and then reduce the strength. Then select a vertex somewhere over nearer to one corner. And with proportional editing, move it up to create a hill, and then with the same vertex selected but a smaller radius for the proportional editing, move it down. And then add an icosphere, scale it up and move it so half of it is sticking out of the crater you created on the hill, so it covers the top of the crater, so it's half embedded in the hill and half. And when it looks okay, add a cylinder. This is going to be a corridor, so scale it up, rotate it through 90 degrees, and then in orthographic mode, move it so it's intersecting with the ground, half underground and half stuck inside the dome. Now select the end vertices and extrude. The default extrusion is at 90 degrees to the surface that you've selected. So by using different orthographic views, you can gradually move the extrusion down. Now finally, at the bottom of the corridor, we're going to have a set of geodesic domes in a complicated structure. So first of all, add a series of new cubes, scale them so they're flatter or thinner, a range of different shapes, and make them so they all overlap with each other. To do the boolean modifier on a group of shapes, you have to put them into a collection. So select all of them, create a new collection containing all of the new shapes. Then select one of the cubes and add a boolean modifier targeting the collection as the object to do the union with. Add a subdivision modifier to this intersecting cube shape and adjust the surfaces of the cubes to get the proportions of the domes when it's half submerged into the Martian surface. The top dome and the corridor join into one object using the Boolean union modifier, apply the modifier, and then delete the corridor, so you have a single object without the vertices penetrating of the corridor penetrating inside the icosphere. Now we're going to convert these shapes when they're all in the right position by adding a wireframe modifier, and this effectively makes a girder structure along the edges with spaces between, so like a geodesic dome. And we can have a quick fly through to see what it's going to look like. We want the unglazed, the corridor and the top dome are going to be unglazed, so we just make a metallic material for those and get an idea of what it's going to look like by changing the lighting to a sunlight, change the strength and angle of it so we get a horizontal, get some shadows cast in the hill so it looks more stark and alien. We can see it's nice and shiny. The bottom domes, the complicated structure of intersecting cubes, we're going to fill with atmosphere, so we'll also make the ground a kind of Martian orange. Move the manikin that we created earlier into the bottom multiple domes. Scale it down so it gives a sense of the proportion. Then duplicate the man and rotate the duplicate around so it looks like two people holding a conversation. Make sure they're standing on the ground. At this point, it should really do what we should have been doing all along. Each time you create an object, you should rename it. So if you double click in the outliner view, you can then change the default cube and icosphere names to person, lower domes. If you look at the wireframe modifier for the lower domes, you'll see the default is to replace the original object. So if you untick that, you'll see that you still have the lower domes, icospheres, and you have the wire mesh on top. So we can apply a different material to the two objects. So we're going to make the original white material into the atmosphere, rename it now to atmosphere, and the frames we're going to make as alloy frames. So we change the shader for the volume from being a surface shader to a volume shader, and we're going to use volume scatter. One thing you notice is that in the eevee shader, that the volume shader produces the cuboid effect. So we have to change the render engine to cycles in order to see an atmospheric filling the domes. Could well be something that Blender fixes in the future. To see what the final render will look like, it's possible to set a rectangular area as a preview using view regions, render region. Draw a rectangle and then start the render image running, often using function key 12. You see that without actually positioning the camera correctly for the final render and then drawing the render region in camera view, you get a random patch of scene rendered. Finally, when everything looks to be working as you expect, you can tweak the render properties and finally untick the option to only render the render region for the final render. One thing we should do is to change the world in the world properties tab with the pink planet on it. Change the environment to a sky texture and choose the Nishita option, and you can then modify the sun size and you can change properties of the atmosphere, air density, dust and ozone to make it more like a Martian sky. Finally, when everything looks good, render the whole scene and save the render.